Good morning guys and welcome to Mind Your Math. Today we are going to do the first chapter of grade 10, which is real numbers. Now I am going to divide this particular chapter into multiple modules. The first part of the chapter I will be doing some concept that you guys have already covered in the lower classes, which is prime numbers, composite numbers, HCF, LCM, and there will be a new concept that we will be learning, which is a fundamental theorem of arithmetic. Before I proceed with the chapter, if you have got any doubts guys, let me tell you, mail me in the mail ID given below in the description box. Let us start with the basic definition of prime numbers and composite numbers. What have we learnt about prime numbers, or what are prime numbers? Prime numbers are those numbers that do not have any factor other than 1 and itself. That is the basic understanding or the basic definition of prime numbers. So numbers like 2, numbers like 3, 5, 7, 11, 13, they do not have any other factor other than 1 and the number itself, correct? Such numbers we call as prime numbers. We know that the number of prime numbers is infinite because the number system itself is infinite. So the number of prime numbers, it goes on and on, it is also infinite. So let us take two prime numbers, 3 and 5. I am multiplying them together in order to get another number 15. What can I say are the factors of 15? The factors of 15 are 1, 15, 3 and 5. Okay. If I take another number which is obtained by the multiplication of two other prime numbers, let us say 2 and 5, I get another number which I can say again is a composite number. The reason being that particular number has got factors 2, 5, 1 and the number itself. So here comes our basic definition of composite numbers. Numbers that are not prime, they definitely have to be composite numbers, or in a more detailed way we can say that a number that has more factors other than 1 and itself are called as composite numbers. So this is a basic understanding which we have already done in the lower classes. You know how to identify a prime number, you know how to identify a composite number. Now that we know the basic concept of prime numbers and composite numbers and what is the definition behind the prime numbers and composite numbers, a common question that can possibly arise is, are negative numbers included in the list of prime numbers? So one thing, let me be very clear. By definition, prime numbers are only natural numbers greater than 1. The negative numbers are not included in the list of prime numbers. So when I say greater than 1, what happens to 1? 1 is considered as neither prime nor composite number, because by the very definition, a prime number is a number that has factors 1 and itself. So here when we are taking into account only 1, the definition does not sink. Therefore, 1 is not considered as a prime number. Now, what about 0? Now, is 0 considered as a prime number? 0 also by definition is not considered as a prime number or a composite number. See, here I have written down the factors of 0. 1 is 0 itself, and any random number will, when multiplied by 0, will give me 0. So the number of factors of 0 are infinite. In the case of composite numbers, the number of factors have to be limited, or we should be able to count or account for the number of factors. But in the case of 0, since the number of factors are unlimited or they are infinite, 0 is neither considered as a composite number and obviously not a prime number. The next concept is the concept of even numbers and prime numbers. What is the only even number that is a prime number? That is only 2. Okay. Any other even number, let us say the next even number that we know about is a 4. 4 also has got factors of 1, 4 and 2. So any even number greater than 2 will have 2 as a factor. So we cannot treat any other even number as a prime number. So 2 is the only even number. 2 is the only prime number. All the other prime numbers, 2 is the only even prime number. Okay. All the other prime numbers are odd numbers. Here I have taken a very simple composite number which is 24. Look at the way in which I have factorized 24. Here you can see I have written 24 in this way, and here you can see I have written 24 like this. What is the difference between these two forms of factorization? In this case, you can see that the numbers that are there in the factorization are all prime numbers. This kind of factorization is called as prime factorization, where there are only prime numbers. Okay, look at this factorization. There are multiple factors. In this case, I have got only a 2 and a 3, 2 occurring thrice and 3 occurring once. In this case, you can see that 24 can be written in many ways. Okay, so till now you guys must be familiar with this kind of factorization wherein we pick out the factors, combination of factors, and then write it down. This is called prime factorization. Now, how do you do the prime factorization of any number is very simple. You go on dividing the number by its prime factors. Sorry. Till we get a 1. So, 2 is occurring thrice and 3 is occurring once. This is called as the prime factorization of any number, successively dividing the number by the prime factors. Now, one thing you have to notice is that in the case of 24, I could have divided even by 3. You can do that as well. You can either start with a 3 or with a 2. You will get the same answer. Here I have taken another number 92 and I have done the prime factorization. I will be getting 2 square into 23. Okay. Here it is a normal factorization. So normally if in your lower classes, if somebody asks you to write the factors of 12, for example, what do you say? You will say that it is 1, 12, 2, 6, 4, 3. Correct? These are the factors of 24, factors of 12. But if I need to, somebody asks you what are the prime factors of 12, how will you write it? The prime factors of 12 will be 2 raised to 2 into 3. 2 occurring, so the prime factors are 2 and 3, 2 occurring twice and 3 occurring once. Okay. So this is the basic difference between normal factorization and prime factorization. And guys, one thing you need to understand is that in the case of prime factorization or normal factorization, 2 square into 23 is the same as 23 into 2 square. Commutative property of multiplication. So it does not basically matter the order in which we are writing the factors. Finally, it comes down to the fact that any number can be represented by only a unique set of prime numbers. There are no other set of prime numbers like in the case of normal factorization. Look at 24. These are the only prime factors that are present in 24. There are no other prime factors that are present in 24. Same in the case of 12, same in the case of any composite number that you are taking. So, we come down to the first theorem of this particular year, which is a fundamental theorem of arithmetic. It is that every number, by that I mean every composite number, can be represented uniquely as the product of primes. So, what do you mean by uniquely? Uniquely means there is only one way in which I can represent the number by the usage of primes. One way means only a given set of prime numbers can give this particular number. I cannot just add any other prime number and hope to get this number. It is not possible. The order in which you write the prime number doesn't matter at all. So every number can be, every composite number can be uniquely represented as the product of prime numbers. Okay. Suppose you have a number n and it is, according to the fundamental theorem of arithmetic, it can be formed by primes p1, p2, p3, etc. depending upon the value of n raised to powers a, b, etc. Okay. Here I have written down the prime factorization of a few numbers. So this is our theorem. Okay. It goes on. And these are a few examples. 128 can be represented in that only there is only one prime number, which is a 2 raised to a power of 7. So there is only p1 and a in this particular number. Let us look at 3200. This is the prime factorization of 3200. You can see that in this case we have got p1 and p2 and a and b. Okay. 1064, you have p1, p2 and p3, a, b and c becoming 1. So depending upon the value of the number over here, the number of prime numbers used in this formation can vary and the powers also can vary. Okay. Okay. So now we have discussed on how to find prime factors as well as the normal factors of any given number. Okay. Now let us take two numbers 36 and 72. Let us write down the factors of 36 as well as 72. 1, 36, 2, 18, 3, 12, 4, 9, 6, 6, 9, 4 I have already written. Okay, I think I have taken all the factors. So, these are the factors of 72. So, I have written down the factors of 36 and 72 in ascending order. Okay. Now, here you can see that they have so many common factors. Okay. The similarity ends here. Fine. So, as you can see, among the common factors, 36 is the largest factor which is common to both 36 and 72. Such factors we call as highest common factor or HCF. Now, this is again a concept that I am just revising. You know what is an HCF and you know what you mean by an LCM, least common multiple. So, again we are revisiting the same concept. So, 36 and 72 has HCF as 36. Now, let us take an example to revisit the concept of LCM or the least common multiple. I want to find the least common multiple of two numbers, which is 9 and 12. So, least common multiple basically means among the multiples of the two numbers, find the multiple that is common to both and that has the lowest value. Okay. So, the multiples of 9 I have written over here, multiples of 12 I have written over here. As you can see, 36 is the LCM of 9 and 12. Okay. So, now that is a basic idea of LCM. Now, before moving on to the various type of sums regarding HCF and LCM, let us first learn how to find HCF and LCM of the given set of numbers. So, in order to find HCF, we will be having, basic methods will be three. The first one, you will be listing out all the factors of the numbers. From those factors, you will find out which is the highest common factor. Okay. For example, you have two numbers 36 and 18. List out the factors of 18. 1, 18, 2, 9, 6, 3. Okay. Factors of 36 would be 1, 36, 2, 18, 3, 12, 4, 9, 6, 6, I am not repeating 6 and 6. Again you have 12, 3, 82. Okay. I have listed out the factors of 18 and 36. From that, I will find out the highest common factor. So, what are the common factors for 18 and 36? I have got 1, I have got 2, I have got 3, I have 6, I have 9. Now, 4 is not a common factor. 36 is not a common factor. I have 18. As you can see, amongst all the common factors, 18 is the highest common factor. So, this is one way of finding the HCF, which is listing out the factors and actually finding out which is the highest common factor. The second method is by division, and personally I feel that this method is the easiest method. Okay. So, I have taken an example over here 32, 18 and 24. You need to find the highest common factor. Take a number that can divide all the three numbers. Fine. So, here I can say that 2 is divided. Fine. Or any other number I can take. No, I cannot take any other number. So, what will I get over here? I will get 16, 9 and 12. Now, is there any other number that can divide all the three numbers simultaneously, or a proper divisor for all the three numbers? You can see that it is not possible. 16 and 12 are divisible by 4 and 2, but then 9 is not. 9 and 12 are divisible by 3, but 16 is not. I cannot find out any other number other than 1. Okay. So, 2 is my HCF. Okay, let us take one more example and see how this method is easier than the other methods actually. Here I have taken another set of numbers 120, 252 and 144. If we are going to list out all the factors individually for these numbers and try to figure out the highest common factor, it is going to take a lot of time. Okay. So, now let us see whether division method is actually easier. One number that can divide all these three numbers, obviously 2. I think even 3 also can divide, but I am taking 2 for now. You people can even start with 3. So when I am taking 2, I will get 60. Here I will get 126. Here I will get 72. Okay, fine. Again, I can divide these numbers by 3. You can even take this is divisible by 2 also. You can take 2. I have taken 3. So what will I get over here? I will get a 20. Here I will get 42. Here I will get, 4. Okay. Again I am going to divide. So a number that can divide all these numbers will be 2 again. I will get a 10. I will get a 23. I will get a 12. I will get a 21. Okay. Now, is there any number that can divide 10, 21 and 12? No, I don't think so, because 21 is divisible only by 7 and 3. 7 and 3, both these numbers cannot divide 10. 3 can divide 12, but 7 cannot. So, all these 3 numbers cannot be divided properly by a single divisor. So, I stop my long division here. So, the product of these 3 numbers will be my HCF. 12. Okay. In the first step itself, if you are able to figure out that all these 3 numbers are divisible by 12, you can do so instead of breaking up into 2, 3, 2, etc. So as you can see, long division is easier than listing out the factors. Now let us check prime factorization, because in grade 10 that is the method they specifically ask in the question paper. Find out the HCF or the LCM of numbers by using prime factorization. Okay. So we will find the HCF of these 3 numbers, the same as that we took before, by prime factorization. Okay. Prime factorization means first we need to list out the factors, the prime factors of the number. So 120, I am successively dividing using prime factors and till I reach 1. So I will get 120 as 2 raised to 3 into 3 raised to 1 into 5 raised to 1. Similarly, 252 is obtained as 2 raised to 2 into 3 raised to 2 into 7. And 144 is 2 raised to 4 into 3 raised to 2. In the case of prime factorization, in order to find the highest common factor, you need to first find out which prime factors are common in all these 3 numbers, or whichever numbers are given to you. You can see that 2 is common and 3 is common. Now, find out the lowest power of 2 as well as 3 in these 3 numbers prime factorization, which means that here 2 is occurring thrice, 2 is occurring twice, 2 is occurring 4 times. Which is the least? 2 raised to 2. Take out that. In the case of 3, you can see 3 is occurring once, that is the least. In both these cases, it is occurring twice. 1. 12. This is how you find HCF by prime factorization. Let us take 2 more examples so that you get a clear idea about this method. I have taken the numbers 120, 288 and 750. I have done successive division using prime numbers and I have taken the prime factors. So 120 is this, 288 and 750. Now I check for a factor that is common in all the 3 cases. As you can see, only 2 is common. 3 is common only here, 5 is common only here, 7 is not, 7 and 11 not anywhere else. So I am taking only 2. In this 2, what is the least power of 2 over here? Here I have 2 raised to 3, 2 raised to 5 and 2 raised to 1. So HCF of these 3 numbers together is only 2. 3 numbers A, B and C are given in this particular form. A is given as the product of x raised to 5 into y raised to 7 into z raised to 6. B is given like this and C is given like this, where x, y, z are prime numbers. So basically 3 numbers are given to us whose prime factorization is directly given in the question. We need to find the HCF. We use the same method because the prime factorization is given to us. We do not have the difficulty of successively dividing with anything. So which are the factors which are common to all the 3 numbers? X is there in all the 3, y is there in all the 3, z is there in all the 3. Our task is only to find out the power that we need to take. x raised to 5, x raised to 4, x raised to 4. So I take the least. Y raised to 7, y raised to 8, y raised to 6. So I take y raised to 6. Z raised to 6, z raised to 6, z raised to 5. So this is our highest common factor. So now I hope you have understood how to find the HCF. Now I have listed 3 methods. One is by writing out the factors of each number individually. The second is by dividing all the 3 numbers simultaneously. Now the third one, which is constantly asked in the grade 10 examination, is by listing out the prime factors. So now that you are clear with how to find the HCF, let us find the 3 ways. Again, the methods are similar. How to find the LCM of numbers. So in order to find the LCM of the given set of numbers or the given numbers, we follow these 3 methods. One is by prime factorization, just like the method in the case of HCF, common division, and writing down the multiples. So let us start from the basic one, which is writing down the multiples. In order to find the HCF, we were writing down the factors. Okay, so now let us take 3 random numbers and try to find their LCM using writing down the multiples method and the common division method before we move on to prime factorization. Here you can see how I have listed down the multiples of 8, 15 and 24. So the multiples of 8 I had to write till 120 in order to find a common multiple with 15 and 24. Since these 3 numbers do not have any other multiple in common which is lesser than 120, 120 is our LCM for these 3 numbers. So sometimes when we write down the multiples, compared to the factors, the multiples can, go on for quite a few numbers before we actually find out the common multiple. So this method is a little laborious, though it's an easy method. So let us check out the second method. Let us try to find out the LCM using the common division method. In order to understand the difference in this method for finding LCM and HCF, I am simultaneously finding the value of HCF also using this particular method. In the case of HCF, what did we do? We took a divisor that was common to all the 3 numbers that is given to us. So 8, 15 and 24, what is a number that is common to all these 3 numbers? You can see that 8 and 15 do not have anything in common. 8 and 24 has a 4 in common, 15 and 24 has a 3 in common. But all 3 numbers do not have a common divisor. So my HCF would be 1. There is no other number that can simultaneously divide all these 3 numbers. That is our HCF. Now how do we do LCM? In the case of LCM, first we check, just like in the case of HCF, we check for a common divisor for 8, 15 and 24. You can see that there is none. So all the 3 numbers do not have. So I take any 2 numbers, any 2 combination of numbers. You can take either 8 and 15, 15 and 24 or 8 and 24. So I am checking 8 and 15. It does not have anything in common. Now I am checking for 15 and 24. It has got 3 in common. So I divide. Okay. 8 not properly divisible by 3. So I write 8 as such. 15 by 3 is a 5. 24 by 3 is a 8. Now all these 3 numbers do not have any common factor. I take out any 2 numbers. 8 and 5 do not have anything in common. 5 and 8 do not have anything in common. But 8 and 8 has got 8 in common. So okay. Now you can see that these 2 numbers have been reduced to 1. So I do not have to bother about those numbers. Now I have to bother about the number that has not been reduced to 1, which is a 5. So I will divide by 5. Now multiply these 3. 8 5s are 40. 40 into 3 is 120. This is how you find the HCF by common division method. Now again for finding the not HCF, LCM. Again for finding the LCM, I always prefer using this particular method because it is the easiest. Let us take a few more examples and see how to find the LCM using this particular method. Let us find the LCM of 12, 18 and 45. These 3 numbers are divisible by 3. 4, 6 and 15. Now there is no number that can divide 4, 6 and 15 all the three numbers, so there is no common divisor. So I check for combinations. 4 and 6 are divisible by 2. I will get 15 is not divisible by 2, so I am writing 15 as such. Now you can see that 2 and 3 has nothing in common, but 3 and 15 has a factor 3 in common. So I am dividing by 3. I get 2, 1 and 5. Now you can see that I don't have to bother about 1 anymore, but 2 and 5, they are remaining, but they do not have any factor in common. So I take out the individual numbers. 2 can be divided with 2, so I get 1, 1 and 5 and 5. So what is my LCM? LCM is the product of all these three numbers, which is 3 2s are 6, 6 3s are 18, 18 2s are 36 and 36 into 5. 180 is the LCM of 12, 18 and 45. You can try it yourself and see whether you are getting the same answer. I hope you have got a clear idea of how to proceed with the common division method. Okay. Let us find out the LCM of 12, 15 and 45 by prime factorization. So prime factorization basically means listing out the factors which are the prime factors of the given number. So 12, the prime factors are 2 square into 3 raised to 1, 15 and 45. I have written it down here. In the case of HCF, we had to take out the factor that was common to all the three numbers. Also, we had to look at the lowest power. In the case of LCM, first you see if there are any factors which are common to all the three numbers. So you can see that in this case 3 is common. Take out the highest power of 3, not the lowest, highest power of the common factor, which is 3 raised to 2. Now 5 is not common to all the three numbers, but it is common to two numbers. Take it. Both are of the same power, so 5 raised to 1. 2 square is not common to any of the numbers, it is there only for 12. Take it. 2 square. So you will get it as 4 into 9 into 5. You will get 180. In the case of LCM, you do not have to bother about whether the factors are common or not. Take out every single prime factor. But if they are common, take out the factor with the highest power. Okay. So in this case, 3 was common to all the three numbers. So I took 3 square, which was the highest power. 5 was common to two numbers. Both are of the same power. So I didn't have to change anything or had a choice in picking out. In this case, 2 was there only for one number. I have taken it out. This is how you do prime factorization in order to find LCM. Let us take a couple of more numbers in order to get the LCM of those numbers. Here I have found the LCM of 24, 48, 60 and 72 by prime factorization. I have written down the prime factorization of each number separately, and 2 is a common factor. I have taken out the largest power. 3 is a common factor. I have taken out the largest power. 5 is not common to any number other than 60. So I have taken out 5. I am getting 720. In this particular sum, what would be the HCF? In these common factors, the least power is 2 square. Among 3, it is 3. 5 is not common, so 12 would be the HCF by prime factorization of these four numbers.